Hi everybody, Mrs. Jentz here. In this homework lesson, we're going to work on some real-life applications of the Pythagorean theorem. Our learning target is I can apply the Pythagorean theorem to calculate the length of a side of a right triangle given the other two side lengths. But first, let's review. The Pythagorean theorem only deals with right triangles. Ooh, look, here's a picture of one. A right triangle always has one right angle, which measures exactly 90 degrees. So a right angle equals 90 degrees. A right angle is denoted with that box you see in the corner. You also need to know a little vocabulary. Here's my right triangle again. The longest side of a right triangle is called the hypotenuse. And the hypotenuse is the side that is opposite the right angle. The other two sides of a right triangle are called the legs. So remember that. Hypotenuse, longest side of a right triangle. The other two sides are called the legs. Now we generally represent the hypotenuse of a right triangle with the letter C and the legs of the triangle with A and B. Now it doesn't matter which leg you call A and which leg you call B. You can flip those around. But we always call the hypotenuse C. Alright, let's get to stating the Pythagorean theorem. We can state the Pythagorean theorem using words this way. The sum of the squares of the legs of a right triangle equals the square of the hypotenuse. Now, mathematicians, of course, also like to represent things with equations because they're super handy. And we can represent the Pythagorean theorem with this equation. A squared plus B squared equals C squared. Here the A squared plus B squared represents the sum of the squares of the legs of a right triangle, and the C squared represents the square of the hypotenuse. Another way to represent the Pythagorean theorem is visually, and I've got a great little video clip that represents actually a proof of the Pythagorean theorem, but it's very visual. So I'd like you to sit back and enjoy that for a minute. So we've represented the Pythagorean theorem three different ways. We've talked about what it means in words, with an equation, and also visually in the video clip. So why is this useful? Well, the Pythagorean theorem is an easy and accurate way to determine length or distance. Any job where precise lines need to be drawn or measured use the principles of the Pythagorean theorem. This can include farmers, construction managers, and map makers. Can you think of any other jobs that might use the Pythagorean theorem? Let's try a real-life application. Painting a wall. A painter wants to know what length ladder is needed so that he or she can reach to paint all of a wall. So the question is, what length ladder does the painter need? And the problem asks us to express your answer in simplified radical form. Vocabulary alert! So just to review what simplified radical form means. It means that there are no square factors under the radical sign. You need to take those out from beneath the radical sign in order for it to be in simplified form. So an example of that here is root 6. You can express factors of 6 as, well, 1 times 6. There's no 1 and 6 are not squares. You could say 2 times 3, and they're not squares either. And those are all the factors of 6. So that root 6 is in simplified radical form. A non-example of simplified radical form is root 20. I know that 20 can be expressed with the factors 5 and 4, and I know that 4 is a square. So if I were to simplify root 20, I would get 2 root 5. So there's your little lesson on what simplified radical form is. So let's talk about the problem. The first thing you should do with any math problem especially with the Pythagorean theorem, is think about, can I represent the problem visually? Can I draw a picture of the problem? And this is an especially good technique to use when you're working with the Pythagorean theorem. So here's my picture. I've drawn the wall and the ladder and the floor. Then the next thing you need to ask yourself, do I have all the information I need to solve this problem? And the answer is no. So I want you to think a little here. What information do I need to solve this problem? Well, you need to know at least 2 of the side lengths. So here's some more information. The wall is 3 meters high. The painter has to put the base of the ladder 2 meters away from the wall to ensure it won't tip. The other piece of information you need to know is which side is the hypotenuse. So I see here that my 90-degree angle, my right angle, is in the corner between the wall and the floor. So my side opposite the right angle is the hypotenuse, the longest side of the right triangle. And in this case, the hypotenuse is the ladder. So now I have enough information to solve the problem. So go ahead and give it a try. All right, here's the solution. First, I state the Pythagorean theorem, a squared plus b squared equals c squared. And then I see that my a equals 3 meters and my b equals 2 meters. So I plug that into the formula and I get 3 squared plus 2 squared equals c squared. I calculate my squares and I get 13 equals c squared. Now I use my knowledge of algebra to isolate the variable c because that's what I really want to know. C represents the length of the ladder, the hypotenuse of my right triangle here. So in order to isolate the variable c, I need to use inverse operations. And I know the inverse operation of a square is a square root. So I take the square root of both sides. And the square root of c squared is just plain old c. And I know that 13 is a prime number, so its only factors are 1 and 13, and neither of those are squares. So I know that root 13 is in simplified radical form. So I like to put my answers to word problems in full sentences. So I write, the ladder is root 13 meters long. So I have a hard time visualizing what root 13 meters is, even though this is how the problem asked us to state our answer. So I just went ahead and plugged that into my calculator and found out that it's about 3.6 meters long. All right, I'm going to leave you with one more real-life application. Often when you're building something like a doorway, or in this case a shower stall, you want it to be square, which means you want to have a right or 90-degree angle. If you have a right angle, the water in the shower stall will drain properly, and that's pretty important. You don't want to have that water around your ankles, yuck. Also, if you want to tile the walls later on, your tile will line up nice and straight. So I want you to think about, how can you use Pythagorean theorem to determine if you have a right angle? We've been talking about we've been applying the Pythagorean theorem to determine a missing side length of a right triangle. But how can we use it to determine if we have a right angle? Think about that. Put your ideas in the open response and prepare to come to class tomorrow to discuss this further. Have a good evening.